Good morning, everyone, for those in North America and South America, and good afternoon to those in Western Africa and Europe. Welcome to the Soybean 360 Agro-Processing in Sub-Saharan Africa. Today's session is Technical Innovations in Edible Oil Processing. And my name is Mark Matlock. I'm the retired Senior Vice President of Food Research at ADM. I retired last year after right about 40 years at ADM. I'm an AOCS past president as well as an AOCS fellow. I've worked on a range of different edible oil applications ranging from developing an instrumentation to measure the oil stability index, as well as involved in some of the first commodity scale commercial enzymatic interesterification.
You are live.
Good morning to those in North and South America, and also good afternoon to those in Europe and Western Africa. Welcome today to the Soybean 360 Agro-Processing in Sub-Saharan Africa. This particular session is Technical Innovations in Edible Oil Processing. My name is Mark Matlock. I'm the retired Senior Vice President of Food Research from ADM Company, where I spent 40 years working on edible oils and vegetable proteins, as well as a number of other things. I am also an AOCS past president, as well as an AOCS fellow, and it's my pleasure today to chair this session. I think you'll all find it very interesting and enlightening. Our first speaker is Matt Williamson. Matt is the Director of Engineering at ADF Engineering, and he's been with ADF for 12 years. His work focuses on oilseeds, corn milling, and the food industry. Matt is a process/chemical engineer with a degree from the University of Kentucky. And prior to his joining ADF, he worked for Procter & Gamble, and he has over 32 years of experience in food and feed, surfactant, and petrochemical industries. So with that, I'd like to welcome Matt, and I think you'll find his presentation very enlightening. Thank you. Matt?
Right. Thank you, Mark. Again, I'm the Director of Engineering at ADF Engineering, and I'm going to be sharing my perspective or the perspective of an A&E firm on what we see going on or have the trends that we have seen going on for the past several years in the oilseeds industry, both locally and internationally, globally, and some of the innovations, the changes, and the drivers for those changes that we've seen in the industry. The key things that we see, of course, as an engineering firm, we see the capital changes that tend to occur. And the three key things that tend to drive the capital spending at manufacturers, first of all, there are the regulatory changes. These are the changes that are often government mandated, but that of course will change from country to country. But there are some trends that tend to transcend national borders. Certainly safety and environmental are huge impactors. Food safety has become more of an issue in the past several years as well. There are also a number of financial changes. These don't tend to be new things that we've not seen before, but those are always big movers. And then the commercial changes are the things that are driven by consumers and consumer demand and ever-changing consumer demand. So just very quickly on some of those regulatory changes, the single biggest impact that we have seen as an engineering firm in the past several years have been regulatory changes, especially in North America and in Europe, impacting or from the impact of combustible dusts and combustible dust explosions. This is something that you're seeing driving significant amounts of capital spending all across North America and Europe. And events continue to occur, and that's what's driving this. In 2017, as many of us know, there was a facility in Wisconsin that had a horrible explosion at the Didion milling facility. And it just continues to highlight why so much attention is being paid to this area. Environmental changes also continue to impact the way companies continue to operate. Foremost amongst those for oilseed plants in particular, and especially those with refining operations, wastewater and handling, how wastewater is handled has had to become more complex and more stringent. So other changes such as this are continuing to occur. But food safety is another huge change. And this is something that, again, we're seeing across borders. There's a lot of demand. Consumers are much more conscious than they had been in the past about such things as how manufacturers are handling food products, things that go into food ingredients. One of the key things that is produced by in the oilseed industry are products like lecithin, and we're seeing more and more lecithin production beginning to occur within major oilseeds producers. They're adding lecithin technology or lecithin manufacturing to existing processes, and these are bringing a layer of food safety requirements that didn't necessarily exist in the past. When you're dealing with something that is a food ingredient, then all of the things like HACCP, which that's identifying the potential contaminants that can occur within a process. Anti-adulteration, that is the prevention of potential human-introduced contaminants or problems that can occur in the manufacturing industry. Other things that are happening along are things like adding nitrogen blanketing to storage tanks and systems. You got to be careful about that, especially if you are storing equipment indoors. When you bring nitrogen into the process, be aware that that can create other hazards as well. And all of this new regulation has required better documentation, and documentation would include updating P&IDs, new technologies to engineering firms such as laser scanning have become prevalent, and now you'll find most all engineering firms deeply involved in laser scanning, that is going into a facility with a scanner and mapping out a 3D model of the actual facility, not just a CAD rendered model, but one that's built from point cloud scan of that facility that gives very, very highly accurate information, especially about older facilities that are not well documented. Electrical health, another thing that has come to the forefront in recent years. So for financial trends, things that are continuing to occur, again, these are not new things. Cost savings has always been a concern, but the conflicting issue that we're seeing more of now is that consumers are demanding, or the customers are demanding, more flexibility in the types of oils, in their specifications, and that has conflicted with the ever-present need for reducing costs within the facilities. And what we are seeing are a lot of newer, smaller facilities that are being built. Most of the new facilities that we're seeing built, not all, but most of the new facilities that we see are smaller, and they're more automated than they have been in the past. And that is with an eye toward this flexibility. Where the older, larger plants, existing facilities, what we're seeing with them is that they're starting to add new co-products such as lecithin that bring higher margins and more cash into that facility. So the oilseeds industry, we have seen for a long time, has been very resistant to change, very slow to bring on new technologies. There are a few key vendors, you'll be hearing from a few of them later today, that are the key drivers of those innovations and new technologies. And some of these vendors have been taking on more and more vertical integration of the industry. They're taking on more and more pieces of the manufacturing site so that there are actually fewer vendors available to take on some of that, some of the new construction. So oilseeds producers tend to stick to their proven technologies, the things that they know, and it's very slow to bring in new technologies. But there are some great new technologies out there. One of those being vertical conditioners. We've seen them for years. We've seen companies like Solex and Crown out there at AOCS pushing the vertical conditioning technology, which is a great technology. That's the way to go. But we're seeing a lot of the manufacturers sticking with rotary steam tubes and older technologies because that's what they're familiar with. And it's very hard to make that step change for them. Hexane extraction, that's still the workhorse of the industry, is not going to go away soon, but we're seeing a lot more growth in older technology, actually, which is mechanical extraction. And you'll see as we start talking about commercial trends why that is. So change is happening. It is out there. You're seeing new things like palm oil and coconut oil replacing hydrogenation because hydrogenation is out. So we're seeing new things having to come in, such as transesterification as required for the palm oil. We're seeing a new awareness of a need for additional storage capacity in facilities. That is one of the main impacts that we've really seen from COVID, especially this past summer. We've seen a lot of companies that have had to slow down production, and with a fear of having to shut down a facility because demand has been reduced, they want to have more storage capabilities so that they can keep their facility operating longer at a slower pace without the concern of having to shut down. The other big change that we're seeing across the board is a new demand for on-site blending of oils. And that's something that had been done just by a few key suppliers in the past, but now it's being done more and more by even smaller manufacturers who have had to bring in this on-site blending capability, which involves a lot of automation and storage tanks, to be able to create custom products for different customers and to provide that flexibility that has been lacking in traditional manufacturing. Other things that are out there, we're seeing extraction of new facilities like sterols from fatty acid distillate. That's another big new demand area that we've seen. Other changes that are occurring in the industry, the digital transformation continues to happen. This is something that's been very prevalent for the past 3 to 4 years. More and more automation is beginning to occur, and that is, again, flexibility, the need for flexibility driving that. But we're also seeing now more of that requirement for remote access, and COVID is driving that even more. So now facilities need to be able to look at their key data, even to be able to make changes in the operation of their plant without even being on site. And that's something that's offered by that remote access technology that is available. The other thing that automation allows, it allows for faster changeovers because we're having to make more custom oils, more custom blends, and you can't afford to continue to have a lot of lost material due to that transition material, the changeovers that occur. So with automation, we find that is more minimized. So finally, the other big change that drives the industry, of course, are consumers. And consumers are very fickle, and they're always wanting something new. They always want the latest and the greatest. And the things that they're hearing that has significantly impacted the industry more than anything else is a trend toward, first it was non-GMO, but now it's more and more organic. They want organic materials. They want organic soybeans, organic soybean oil. Trans fats, as I've already mentioned, that's gone. And transesterification has kind of been put into that place to bring in other oils like palm. But there is some hydrogenation still out there. There are still some companies still doing hydrogenation, mainly for non-food applications, because lubricants and other materials still need that type of capability in their oils. But the organic trend has been very, very prevalent. And the key to that is, first of all, you can't use hexane and call it organic. And that, with the bulk of the industry using hexane extraction, it means it's been very difficult to find some of that organic capability. And that's why we're seeing that push toward more new, smaller mechanical extraction facilities. The other thing that we're seeing are some alternative extraction methods, and I'll get into some of those. But the other key issue, and this is something that has a tremendous impact on areas like in Africa, where organic soybeans are available. Those soybeans, organic soybeans, are hard to find in the U.S. in particular. So the United States is having to import more than 70% of its organic soybeans, and that is a very high demand market now. So currently, the U.S. is importing most of its soybeans from India. However, that is an area that is readily available to be able to get into, because there have been some issues with the harvests recently in India. So it's driving up the price of organic soybeans, and that is a tremendous opportunity to get into that. So again, mechanical extraction, we're seeing a lot of that in new facilities, particularly to feed the organic oil demand that is growing very, very rapidly. There are some other new oils and new markets that are being penetrated. Biodiesel's been around for quite a while now. That market continues to grow, and we expect that market to continue to grow very rapidly in the foreseeable future. Other niche oils are starting to come into play. However, demand for those tends to be much smaller. Those tend to be those smaller manufacturers that are getting into some of those niche oils. And we're finding lots and lots of small players trying to get into that market. Not as much from the big name producers. And those niche oils involve some other extraction technologies, too, that we are seeing quite a bit of: ethanol extraction for some new materials. With ethanol, there's a claim that they can maintain the organic claim when using ethanol. And the other that we're seeing is CO2. CO2 is a very unique technology. It's fairly capital intensive, but this is something that's used for things like CBD oil. And it offers a very, very clean oil, very, very high purity, because it's driven by changes in pressure more so than changes in temperature. And you can get a very, very clean material, and it doesn't add heat to your meal. So if you've got a meal or a protein concentrate that is very sensitive to temperature, this is a technology that's available. Algal oils, we're still seeing having trouble penetrating the market beyond fuels, but it is still out there. They are still making that push. Protein isolates are the main thing that we're really seeing from a co-product standpoint, where many of the smaller facilities are making more money from the protein isolates than from the oil. So that's definitely been a push for not only for human food, but for animal feed and aquaculture, which has a huge demand for these protein isolates. And they have some very, very interesting materials that they're looking at for protein. With that, I think I am about done. So I will stop sharing.
Matt, thank you very much for that presentation. While we wait for the audience to submit some questions via the chat or the direct mechanism, I had a question. You mentioned ethanol and CO2 extraction technologies, and it seems like ethanol would be a little bit easier, a little bit more, conventional types of things. And I know there's a higher heat of vaporization that you would have to deal with versus ethanol. But, what are the sort of the pros and cons if you were thinking of sort of migrating from a hexane extraction to an ethanol extraction?
Well, the big problem with ethanol extraction, of course, is the recovery of that ethanol is fairly difficult because, as you know, when you try to distill it, ethanol creates an azeotrope. So you've still got water in it. You've still got about 8% water in it that you've got to deal with. And if you want to put that back in your extractor, well, that'll turn your meal into mush.
Oh.
So that's a problem. So you have to, we see it more on some non-soybean type of products that don't have that sensitivity to the moisture. Otherwise, if you're going to use that, you'd have to have some drying technology like a mole sieve to take the water out of that ethanol if you're going to be able to recover it. And you need to be able to recover it to keep it economically viable.
Sure. Well, if I guess, I was thinking, it would be kind of substitutable, but if you have to put in a mole sieve, drying distillation system, then that brings the capital cost up a bit.
That's exactly right.
Yeah. Okay. Let's see if there's any questions from the audience yet. There's one question here. It's asking a little bit of detail about the trend in organic soy oil. Do you see it growing more in the EU or in the US?
Actually, the growth rate would be higher in the US. That's because they're starting from a lower level. Organic demand in Europe has been high for a long time. Therefore, that's already, the growth is there, but that's already plateauing. It's already the standard. In the US, it's something that's growing very fast, but it's still way behind what you find with traditional soybeans.
Okay. You also mentioned transesterification. I know in Europe, it started out being largely chemical interesterification. And as I mentioned, or maybe I didn't, I was involved in some of the first commodity-based enzymatic interesterification. I just wondered, what do you see around the world? Is it more popular in certain areas, or is it, what's driving sort of the difference between chemical and enzymatic these days?
I'm really seeing more and more of the enzymatic everywhere we look.
Everywhere.
So, especially in areas where the soybean oil is being imported. So these are facilities near the coasts that are bringing in shipments of palm oil from Southeast Asia or from Africa. You'll see a lot of those facilities building more and more of the enzymatic esterification. I really haven't seen much at all of the chemical.
Okay. Let's see if there's any other questions from the audience at this point. No, doesn't appear to be. You also mentioned just a little bit about CO2, and it was primarily being used for some really higher value oils. Do you see, other than the CBD, CO2 being used for any higher value vegetable oils, or is it largely kind of in that almost pharma neutral?
It's unlikely. It would have to be very high value because the capital cost of the CO2 systems makes it prohibitive for any large facility because you're dealing with some fairly high pressures to maintain that liquid CO2. And that lends itself to a very small processing.
Yeah. Okay. Well, like you said, it's likely that we'll see hexane for quite a while, I suppose.
It's not going away.
Not going away. All right. Well, I think that's, let me see if there's any questions that have popped up. Nope. So that pretty well concludes the first session. And thank you very much, Matt, for making yourself available and enlightening us on recent innovations in edible oil processing.
All right, thank you, Mark.
Thank you. Our next speaker today is Bart Schols. Bart is in technical sales support for Desmet Ballestra. He's coming to us from Belgium today. He has a master's degree in agrochemical engineering. He worked in the edible oils industry for 5 years in refining plants as a project manager, and then worked on process optimization in a fractionation specialty plant. He joined Desmet Ballestra in 1998 as a process engineer. And after some years of product management, he was the engineering manager for the refining and modification department. And he just recently moved into the group sales support. So his presentation on soybean oil refining is something I think you'll find very interesting. Bart, welcome today, and thank you very much for your talk.
Okay. Good afternoon, everybody. So my name is Bart Schols. Mark, thanks for the nice introduction. And I'd like to thank also the previous speaker, Matt, for the very nice general framework of tendencies in the refinery. In my presentation, I have decided to zoom in on the first steps of the oil refining. That means where we have the separators, so where we have neutralizing or degumming. So it would go like this. I would give an introduction where I will explain shortly the difference between chemical and physical refining. Then we will zoom in a bit on chemical refining, and I will introduce nanocavitation technology. And then, as alternative, I will zoom in on physical refining and also what is actually happening in degumming processes today with the very fast evolution of enzyme technology. And then, to be complete, we will also shortly discuss water degumming and the potential use of enzymes in water degumming with, as alternative, a gums deoiling process. So the tendencies in refining are actually everybody who is producing oil will always be between different requirements. Of course, the oil quality is one criterion that you have to respect. And then the other criterion is the refining cost. And that all in a framework of more and more evolution towards sustainability. So less environmental issues, less energy consumption, and so on. So basically, on the one hand, in an existing plant, you can play with the refining conditions. But on the other hand, for a new plant, of course, all depends on the plant configuration. That will actually define how you can, which process you can run. So the quality is one thing, the cost has to be minimized, there are all kind of legal requirements as environmental. And then, of course, the sustainability is something that comes more and more in the picture. So we have to look for processes which consume less chemicals, less energy, give less effluent, which are safer, and as also already said, there is a tendency towards more mild operating conditions to have less negative side reactions. But when for this presentation, I'd like to simplify a bit the issue. So, of course, things are more complex than that, but to explain the difference between chemical and physical refining, I think we have to zoom in on the two major components which we have to remove from a crude oil. So, of course, there are the free fatty acids which have to be removed, and the phospholipids which have to be removed from the oil. The FFA can be removed basically as soaps after the addition of caustic soda, and that is what we call chemical refining. And as an alternative, the free fatty acids could also be removed from the oil by distillation in the deodorizer. Now, soaps and phospholipids are emulsifiers. So unfortunately, when you try to remove that from an oil, unavoidable there will be losses going together with it, simply by the fact that these molecules are emulsifiers. And the soap stock or the gums is a water phase, so you get there an extra loss. On this slide, you see on the top, you see the crush, the preparation and the extraction. And then you have the water degumming. And then you have on the left side the chemical refining, and on the right side the physical refining. It looks more or less similar, but as said, the difference is that the fatty acids will be removed with the soap stock in a chemical refining line, and in the deodorizer with the distillate in a physical refining line. So the exact point of when chemical or physical is the best thing to choose depends, of course, on many factors. One of the factors is the FFA content of the oil, but another factor is the cost of the oil. The lower the cost of the oil, maybe the more in favor of chemical refining, but the higher the value of the oil, the more in favor of physical refining. Also, what is more and more, the effluents are a real concern. And for that reason, there is also a tendency to go to physical refining. Actually, for the people who are in R&D or who are not in production, it has been a dream for decades to move for all oils to physical refining. But the reason that that is not yet done is because it's not always so easy. So I would give this comparison between chemical and physical, let's say, before we introduce the new technologies. I would summarize chemical refining as follows. It is applicable for all oils. It is not too complicated process. It allows for mild deodorizing conditions. That is all positive, but let's say the side effect is that you produce soap stock, that you need a soap stock splitting, unless you have an integrated plant where you can dose the soap stock on the meal. And then you have their effluent with phosphates and sulfates, which is sometimes a headache depending on the local environmental legislation. The distillate that you will produce in the deodorizer will have low FFA, but higher unsub content. So I would say it has been, and in most plants for soya, it is installed like that. It is a reliable process for standalone refineries, and the process can deal with virtually any oil quality. Now, when we look to a physical refining, that is, of course, a must for tropical oils. And it is a process that goes fairly well for easy, fresh, soft oils. It is a process which can be difficult for old, low-quality soft oils, which are traded or stored for a long time. Also, if people want to go for physical refining, the deodorizer has to really work as per design with the correct vacuum to be able to strip the fatty acids from the oil. This process gives less effluent, no soapstock splitting, and gives a higher FFA distillate. So I would say this is a good option for integrated plants, and it is, for instance, for soya and corn oil, obvious to go for physical refining. For soybean oil, there is sometimes resistance because the quality is not always allowing for this process. So when we look at the neutralization line, to get it right, the main thing is to do the dosing of chemicals correct. So that has all has to be automated. The exact quantity of chemical that you dose has to be correct. But it's more complex than that. You also have to use the right concentrations. So for instance, not only the quantity of caustic is important, also the exact concentration that you work with. That is then again dependent from the FFA. And also the right excess is important to get a good separation on the separator. Of course, there are many electromechanical issues which have to be properly selected to get a good result, like the disc stack, the exact pressure on the hydrohermetic feet of the separator, the back pressure, and so on. So I would say it is a reliable process, but it gives soap stock, and you have the effluent. So now the question is, how can we further improve chemical refining? We already said that the soaps and phospholipids are emulsifying components, and so they give oil loss. Now, if we can tackle this oil loss one way or another, we are a step ahead. So which technology could help us for that? When we look at the history, the last 50 years, you see that actually for chemical refining, 50 years ago, people were dosing acid in the storage tank. And then after that, people invented to start dosing in line, in the neutralizing line. And we see also that mixers have evolved from static mixers to dynamic mixers to high shear mixers. And so the question is, can we even go further in this mixing of chemicals in the oil? Well, we have introduced hydrodynamic cavitation technology in the chemical refining process. So basically, it is a static mixer, to simplify it, but with some special geometry, with some internals with a special geometry, which allow to have a controlled cavitation. I know that when you hear cavitation, most of you will think about negative things of cavitation. Cavitation can destroy a pump. It is something you don't want in a centrifugal pump. But here the cavitation is used to increase the shear rate and to take benefit of it. And it's also a controlled cavitation, so to assure that there is no damage of the nanoreactor. We worked for that together with the company CTI, and a nanoreactor is not very big. What we have observed is that with this technology we can drastically reduce the chemicals. We can also minimize the excess, and due to that there is a direct impact on the yield of the line or the oil losses, which are reduced. Here is a picture of how it looks like. So the advantage is it's not taking a lot of space. You see this rectangular box in the middle of the screen. in that box, there are these nanoreactors. And it is a kind of static mixer, but it works with a pressure difference of 60, 70 bar. So a very high pressure difference. And to overcome that, we are using a multicellular pump, which you see on the right side against the wall. That is actually the most reliable pump to go for this, to feed this nanoreactor. What we also see on the result is that we have a lower soap content. And so you could work with less wash water to get the soaps down after the second separator. And there are even some customers who are skipping the washing step. So to summarize the advantages of nanotechnology in neutralizing, we can drastically reduce the need of phosphoric acid. And with that, the caustic soda goes down. And also the need of excess is actually eliminated. And on the quality, we see that we get a lower soap content and lower phosphorus in the neutralized oil. We see also a reduced oil loss. This is actually how it looks like, these reactors. And according to the capacity, they will be built in a skid. And we have, for instance, on the right side, you see 3 nanoreactors in parallel to reach a certain capacity. At the bottom, you see again the multi-stage centrifugal pump, which is a more economical alternative to the piston pump on the right side, which is rather expensive. Here in this slide, you see some results that we had with and without nanotechnology on the use of chemicals and also on the result after neutralizing. So this is, I think, really something new in neutralization technology. And it is also something what is in line with the tendency to go for a more sustainable process. So using less chemicals, less water, and this is also allowing to increase the yield and to lower the operating cost. Then the second part of the presentation is on physical refining. Actually, when we look at degumming the last 30 years, and we look at the history of the processes that were introduced in the industry by all kinds of suppliers or even by refiners themselves, actually one could ask a question. If the first was invented, why people were still looking for a next degumming process? The reason is very simple. Because an oil can be easy or difficult. And it's not like that every process could simply reach the results that were expected from it. So people were continuously looking for improvements on the degumming process. And when you look at the history, you see that actually, just like in neutralization, the dosing itself is very important. The automated correct dosing of chemicals, then the ice-shear mixers are extremely important to get a good result. We also see that the dilution of acid is, especially in degumming, is very important to get good results. The pH correction has to be done to be able to remove the phospholipids correctly. Then we have things like 2 steps degumming with recycling of the heavy phase. And even some people go for 3 steps in degumming. And also there can be a maturation step at reduced temperature. These processes are still used today in the industry. And for some oils, they are fairly reliable as there are sunflower oil or corn oil. For soybean oil, it's less common to use this process because it's not always easy. It depends a lot on the non-hydratable phospholipid content. And we should not forget that at the end, the target is to get the phosphorus low enough. If not, we will be penalized in the bleaching downstream. So when we now look at the chemistry of phospholipids, basically we have 4 types of phospholipids. So a phospholipid looks like a triglyceride. You have 2 fatty acids on a glycerine molecule, and then you have a polar phosphate group on the 3rd connection point of the glycerine. And depending on what you have here, this X, you have actually 4 types of phospholipids. And 2 of them are fairly hydratable, and the 2 others are less hydratable. So if we could find a way to destroy these phospholipids, which are emulsifiers, we could reduce the neutral oil loss. Since a long time in biochemical textbooks, these enzymes were described. People who study microbiology or biochemistry, they are well aware of that. I think the big difference with 50 years ago and today is that these enzymes are becoming more and more commercially available. When Lurgi introduced the first enzyme degumming in Germany, that was still with enzymes which were extracted from animals, and that was not a real big success. But I would say from the moment companies like Novozymes or DSM started to introduce enzymes, actually the whole thing is going faster and faster, and there are becoming more and more enzymes available, and also cocktails are becoming available. So if we think out of the box on this scheme, where could we actually think about using enzymes? Well, you could even think to use it in the extraction, but we could use it everywhere where phospholipids are a problem. For instance, in the water degumming, we could use it, or we could use it in a chemical refining, or we could use it in the deep degumming, or we could use it to process the gums downstream. It's also important to make a difference between deep degumming and water degumming. So the purpose of deep degumming is to really remove the phosphorus below 10 ppm. If we do a water degumming, normally we have to reach a phosphorus spec of like less than 200 ppm for soybean oil. And in a typical water degumming, you could achieve that unless the beans are of lower quality and contain a lot of non-hydratable phospholipids. But if we look at the different enzymes, we see here on this slide where actually these enzymes are working. So an enzyme is a protein with catalytic activity, which is produced in microorganisms. And these enzymes are basically cutting the molecule. For instance, PLA1 is cutting off a fatty acid from the phospholipid molecule. And a PLA1 is a phospholipase which cuts off the middle position. And a PLC enzyme is actually cutting off the complete phosphor group. Then you see, as a result, with the PLA, you get a lysophospholipid, but with the PLC enzyme, you even get only diglyceride as a result, plus a water-soluble phosphor group. Diglycerides are actually neutral oil. So here we have a typical degumming line, and we have shown how this could be modified for enzyme degumming, deep enzyme degumming. The acid conditioning upstream remains very important to make the phospholipid accessible for the enzyme. And we also have to correct the pH for the enzyme. We have to cool the oil, and we have then to dose the enzyme in the oil. And in this reactor, the enzyme will do its work and try to destroy the phospholipids as good as possible. So typically we work with 2-3% water, and the temperature will be 50-60 degrees for let's say for Licitase ultra. There are today other enzymes which allow for a higher temperature, but I would not go into that detail today. Of course, the reaction time is also something that can be discussed, because the longer the time, the less enzyme we will need to get the expected result. So deep or complete enzyme degumming can be applied both on water degummed oils or on crude oils. It is still today always done with PLA1 enzymes. With a PLC type of enzyme, until today, it is not possible to go for deep degumming. Usually the phosphorus remaining in the oil will be like 50 ppm. Also, economically, at the end, the enzyme degumming is yield driven, because the enzyme has a cost, and so the purpose is to have less neutral oil loss. So in other words, the lower the phosphorus content in the oil, the less attractive to go for enzyme degumming. Apart from less oil loss, there is also more distillate, because when you cut off a free fatty acid molecule, you increase the FFA of the oil in degumming, and that will be removed in the deodorizer with the distillates. But as a conclusion, I would still say that the enzymes will be one factor to move more from chemical to physical refining. But we should not forget that at the end, we really have to aim at phosphor less than 10 ppm. Because if you go with 20 ppm to the bleaching, you will be penalized another way. I would also like to highlight that the acid conditioning remains very important also when we do enzyme degumming. So the enzyme can, of course, be applied for different oils and also in the pre-treatment of a biodiesel plant. So this is again summarizing what I already said. We have to reach low phosphorus, and the yield improvement depends on the initial phosphorus content. And the free fatty acids will be valorized in the distillate. So now, to be complete, I also would like to shortly talk about the water degumming bit, because all the traded oils are first water degummed normally. If not, it will be a big headache to ship crude oil containing 800 or 1200 ppm phosphorus. So in most crushes, there is a water degumming installed. And there also is a potential to use enzymes. The advantage is that you do not have to reach deep degumming, and we can thus apply different different enzyme, PLC enzyme. So in an enzyme-assisted water degumming, the phospholipids will be converted into diglycerides. The only thing is, where PLA1 and A2 for the deep degumming can destroy any of the 4 phospholipids, the PLC enzyme unfortunately is not cannot destroy all the 4 phospholipids, and that is also the reason why it cannot reach yet deep degumming. So usually the phosphorus will be around 50 ppm at the outlet of an enzyme-assisted water degumming. But, and especially for soybean oil, if we have there 2.5% phospholipids, the potential of yield increase is huge, of course. Because a phospholipase C is simply cutting off the phosphorus head, and what remains in the oil is the diglyceride. And diglyceride, we can say that it is neutral oil, actually. Here is a calculation which goes back to the molecular weights and the stoichiometric chemical reaction, but it's calculating basically the increase of diglyceride based on a phosphorus content of 845 ppm. Here also is we give actually the difference in FFA and diglyceride for an enzyme assisted water degummed oil compared to the crude oil. So you see diglycerides are increasing and FFA is also increasing because today the PLC enzymes are commercialized as a mix also with PLA1 enzymes. Unfortunately, as said, it is not possible yet to do deep degumming today in the water degumming when using PLC enzymes. But the potential of yield increase is actually very high with this process. I think it's more and more applied in the water degumming, at least if the lecithin is not having a higher value. Because another tendency is for like organic soybean oil or non-GMO soybean oil, is that lecithin could have a higher value than neutral oil, and in that case, of course, the enzyme degumming cannot be used. Economically, we also have to look at the difference in value between oil and meal. So the bigger the difference, the more money can be spent for the enzyme. The lower the difference, of course, the less money that can be spent for the enzyme. So as a conclusion, enzyme-assisted water degumming on crude oils, usually with PLC or PLC-PLA cocktails, and applicable if the lecithin is not attractive. Higher oil yield is the main driver, and deep degumming is not possible yet. The economics is a pure economical calculation. Just to be complete, we have also developed a process where the enzyme is not dosed in the oil in the degumming line, but where the gums are processed on the site. So after separating the gums from the oil in the separator, we have a process where we treat the gums itself with the enzyme. This has several advantages. One of them is that we need much less enzyme. The second advantage is that the oil that you recover, you do not have to add it to the oil. You can also sell it a different way because this is an oil containing a lot of diglycerides. And diglycerides is something what you do not always want to add to the oil. So you have the possibility to sell this oil separately. So the advantage of gums de-oiling is that you can process the gums offline, and that you also, the additional yield that you collect it separately, and you can give it different destinations. The flexibility is, of course, the same as for a normal degumming. You can always switch the use of enzymes on and off according to the meal price or the lecithin price. So as conclusions, and I'd like to start on the right side, PLC degumming and water degumming has a huge yield increase potential. And there is, as alternative, the gums de-oiling process with the same enzyme. But this can never reach deep degumming. If we want to do deep degumming to go for physical refining, we could indeed introduce enzymes to get even better result. But as always, the oil quality will be a limiting factor. So with the use of enzymes, we can further reduce the loss. Also, when using the enzyme for deep degumming, the acid conditioning remains a key factor. And for the physical refining, I would say somehow the oil quality at the inlet is still one of the factors not to be overlooked. So when we go to the chemical refining, and this is actually for soybean oil mostly applied, it remains highly reliable. It can deal with any kind of quality at the inlet. Unfortunately, there are the high oil losses and the soap stock splitting which is required. But with the nanotechnology, these negative effects can be somehow mitigated. So because we can use less chemicals, we have less losses, and we can have even more distillate produced in the deodorizer. And of course, we will have less sulfuric acid usage in the soap stock splitting, so also a lower effluent load. That's about it. Thank you for your attention.
Thank you, Bart. You did get several questions from the audience, but in an effort to try to keep things on time, I think we probably should move on to the next presentation.
Okay. Sorry it took some more time.
No, that's quite all right. If you can make it to the panel discussion, it would start at 10:05, so in about an hour from now. So,
yeah. Okay.
All right. Our next speaker is Richard Ozer with Crown Iron Works, based in the Minneapolis area. Richard is a technical sales manager for specialty products at Crown Iron Works. He joined Crown back in 1997 and since then has been involved in applying Crown's existing solvent extractors in new applications. These new applications include things like soy protein concentrates for aquafeeds, desolventizing palm kernel, washing polymers, food grade citrus fiber, and other applications. And today he's going to talk a bit about white flake desolventization of oilseeds. So Richard, thank you very much, and I'll turn it over to you.
Thank you very much, and thank you all for taking the time out to listen. I'll try to make up some time if we can. The topic today will be about white flake desolventization, which is really about improving the value, increasing the value of your typical oil seeds. And when we talk, for the most part, the experiences with soy, but recent experience has been with other products such as canola or rapeseed and sunflower seeds. So whenever we talk about soy, please keep an open mind, and we'll be talking about other applications as well. But we're going to start with, pardon me, yeah, here you go. We're going to start with some definitions first. What is a white flake? So white flake is a hexane wet flake, and I'm going to expand that also to say solvent wet flake, because it can be alcohol or other solvents as well that are desolventized at low temperature to maintain product color and protein dispersibility. It's been applicable to soybeans as well as other oil seeds such as canola, rapeseed, and sunflower. PDI is protein dispersibility index, a test to indirectly measure the digestibility or viability of a protein. It's also an indirect measurement of the heat treatment of the product. SPC is soy protein concentrate, a highly concentrated soy protein, 65% and above protein level on a moisture-free basis. And it's most often processed with using white flakes with a PDI between 65 and 70 for food applications. Soy protein isolate is even more highly concentrated at 90% protein concentration, again, moisture-free. And it's processed using soy flakes, there to improve yield. PDI is, let's say, 90 and above. Here you'll see a few pictures of white flakes. The one on the left is for making soy protein isolate. It's a 90 PDI. The color is a little bit better, although I don't know that you can see it in the photo here. It's a thinner flake because we're going to dissolve this in water. And then the 60 PDI white flake for making SPC, you're going to see that the solids are thicker and there are less fines present, because that will be a water extraction, and fines, we don't like fines in extraction plants. The typical specifications will be really max PDI reduction between 5 and 7 points. If you bring in something with a field with from the field with a 90 PDI, we'll deliver it at 83, or at 95 PDI, we'll do it at, let's say, 88. We generally target less than 350 parts per million residual hexane in the product. Applications, where am I going to use this? And what we're going to say is that typically a white flake will have a sales value probably 30 to 50% higher than the typical high pro meals. So where are they used? The 90 PDI material, again, soy protein isolates, although there are other applications as well. The 60 to 70 PDI products, the big user is soy protein concentrate, but we also use this in bakery mixes where people have a requirement for gluten-free flour, donut mixes, the pastas. A very, very big use for white flakes, 60 to 70 PDI white flakes is texturized vegetable protein. What is that? That is a meat analog. That is a meat analog, and it's a substitute for meat. Basically, much better for the environment. It's a new product that's on the market, and quite frankly, again, what we do is we take the white flakes, we texturize it, we make it into a crumble that can be added to meat, or it can be served as a meat substitute by itself. Fully toasted, this is enzyme inactive at this point. It's used as a milk replacer, it's used as a filler in meat products and hard biscuits, and it's used as a flavor carrier. How do we make them? The work started in the 1940s and 50s when the USDA was looking for increased application of soybeans in the market and to make them digestible for ruminant cattle. They had to reduce the urease and the other anti-nutrients in the soybeans so they could sell the soy as a feed for cattle, piglets, and poultry. The work that was done by USDA showed that urease and most of the anti-nutrients became more sensitive to heat as the moisture content in the product increases. And so this work resulted in the development of the toasting process that we know today. In a desolventizer toaster, what do? We basically increase the moisture concentration so the proteins and the urease become more sensitive. The result of the work is really shown in this graph here that basically tracks different temperatures, moisture concentrations over time, and then the denaturization in terms of a percent. Basically, when the moisture concentrations of your material are low, you'll see that, let's say 6% at 80 degrees C, the PDI remains almost constant. The drop is less than 5 points in 30 minutes and 6 or 7 points in an hour, and not very much different after an hour and a half. As the water content increases, you can see that after 1 hour at 15 to 20% water, after an hour, the PDI drop goes up a little bit, more so after 90 minutes, and after 2 hours, there's a pretty significant drop. When the product is dry at 8%, it's pretty stable for the first 30 minutes, but then it takes off at 120 degrees C. But at 115 degrees C, and more important, 20 to 30% water, and that's really down as low as 18% water, we see a reduction in PDI of 60 points in 30 minutes. So the graph shows that at 80 degrees C, the protein is relatively stable for extended periods, even with moistures up to 20%. But when temperatures exceed 110 degrees C, rapid protein denaturization occurs regardless of moisture content. But when the moisture content goes, like it should be 18% at 110 degrees C, we see that rapid denaturization or reduction of PDI occurs. And so this is where we make the 30 PDI for cattle or 20 PDI for poultry. And the rules are being, let's say 18 to 20% moisture, 110, 115 degrees C, and 20 to 30 minutes, you'll have a product, a high pro meal that will be suitable for feeding to cattle and poultry or other ruminants. So let's take this and now let's apply it to humans or to higher value type products like the calves milk replacer we talked about, or other products here, and the meat analogs. And we say that, how can we improve the value and then use the information we've gathered to improve the value of the product by making a higher PDI material. So we know that 10% water, the white flakes are resistant to denaturization for 30 minutes. We also know that when it's dry, in other words, without condensing sporage steam into the white flakes, it's possible to remove the majority of the solvent at atmospheric pressure without denaturing the protein. So as far back as 1967, a two-step method for desolventizing white flakes was developed. The first was to remove the bulk of the solvent at atmospheric pressure. Hexane's low boiling point of 69 degrees C protects the product at the low temperature range at atmosphere. And once the majority of the solvent has been removed, we fully desolventize the white flakes under vacuum and low temperature to prevent protein denaturization and also increase in color or decrease in color content. So it becomes possible to fully desolventize the soy and other oilseeds while minimizing the reduction in PDI. We had two different approaches depending upon the size of the plant and the application of the white flakes downstream. We can do it with what we call a downdraft desolventizer using indirect heat exchange at low temperatures. Desolventization takes 10 to 15 minutes, but from the chart before, we know there's no reduction in PDI. Conveying is mechanical, so the flake integrity is maintained. Or we have an alternate approach, the flash desolventizer, where heat exchanger is direct. In other words, superheated solvent comes in contact with the flake directly, and we desolventize the product as quickly as possible at temperatures from 150 to 100 degrees C. and then discharged to a lower temperature area right away. Material is conveyed pneumatically and superheated hexane at high velocities, so residence time is very short, 2, 3, 6 seconds, and you've gone from, let's say, 30% hexane to 2% hexane. The downside is that the turbulence and high velocity break flakes, and you have higher horsepower involved. The upside is that your color is very, very good. In both cases, the DDD on flash desolventizer, the final stripping takes place under vacuum and at low temperature to minimize protein denaturization. The downdraft desolventizer is it's an indirect heater, and what we're doing is basically we're indirectly, in other words, we have a steam chest, and basically these red areas here are channels for steam. We're heating a plate. We're using introducing feed material here. We're using paddles to draw the material down the slope. Inside or on top of the heat transfer surface, it comes to the end of the slope here, and you'll see that the material falls off the end of the tray, and it's gathered by the second tray underneath it. So the material is moving very straightforward on top of the trays in a snake-like pattern. And basically what happens is two things, is that we're turning the material over often. So we're always presenting hexane to the surface. So the evaporative, the boiling point of the hexane is protecting the material. The other thing that's extremely important is we have a plug flow or first in, first out situation here, so that material that enters, we can say with a surety that the residence time in the vessel is designed, let's say 12 to 15 minutes, but plus or minus no more than 30 seconds to a minute. So we have uniformly treated the white flakes. We have a feeder that will gently distribute the material over the width of the device. There's gentle turnover to keep the, like I said, the solvent wetted flakes in contact with the heat transfer surface without breaking the flakes. And if necessary, let's say when you're running at 50% of rate for some reason, you can turn the temperature down on and the pressure down on each tray to really control the heat input to the product. The next step, the next alternative is the flash desolventizer. And these are built for up to, currently built for up to 1,000 tons per day input of soybeans. Again, it's a pneumatic conveyor. Our feed point here is right here, just above this rotary valve. We're providing duct work that's going to provide the required residence time for the solids. The solids are removed from the system in a cyclone. There's a fan, a specially designed fan to work with solvent vapors. We recirculate, and the majority of the hexane or solvent will go back to through a heater where it's returned, and basically we start the process again. To keep the system in equilibrium, we have to vent any evaporated solvent away. So after the fan, there's a pressure control valve that vents the solvent and keeps the system in equilibrium. Direct heat transfer device, high turbulence to ensure good heat transfer and uniform product treatment. This is a first in, first out design also. Where the residence time, like I say, instead of minutes, 12 to 15 minutes is 2 to, let's say, 4 or 5 or 6 seconds. And if you look at this device here, you'll see this is nothing but a bunch of turns. And this is an existing, pardon me, I'll be showing you an existing installation in just a minute. There's a lot of horsepower associated with this elbow, these elbows and ducting arrangement that we have set up differently so we can provide the residence time without paying for all the horsepower. This is a flash desolventizer that was installed in Iowa, roughly 520 metric tons per day of white flakes. And this is a little one, basically a downdraft desolventizer for 100 tons per day of white flakes. The space taken up by this device here is perhaps 10 meters by 15 meters by 8 meters high. And you can see this is taking up almost a building. So the downdraft desolventizer packs a lot of heat transfer area and a lot of volume into a very, very small device. What's important to the vacuum stripper, that final step? So what are the essentials? We need to maintain product temperatures below the protein denaturization point, and even while adding stripping steam. So for soy proteins, the temperature that most of these proteins will denature at is about 80 degrees C. But we've been involved with some other proteins where we require temperatures as low as 57 degrees C. And basically, you're able to control the temperature that the solvent boils off at by controlling the vacuum. Simple as that. So lower boiling point is obtained by lower vacuum, and again, good product temperature control. So what else is important? We've got to provide residence time, because now in the first step, we're dealing with solvent that's on the surface of the product that's easily removed by evaporation. Now we need to provide time for the solvent to get out from the center of the particle to the surface where it can be carried away. So we provide several different driving forces to pull the solvent out. We've got to provide residence time. We also have to provide, we do operate under vacuum required to obtain stripping without condensation, because condensation results in bacteria growth. Condensation is water. We have a high protein feed material, and it's warm in areas and not necessarily hot. So we need to operate under vacuum. We also need to get to low ppms of hexane for storage and transport. And again, our target is the 350 ppm for traditional oilseeds. Another argument for vacuum, quite frankly, is you'll use less steam. We'll use stripping steam to achieve the low ppms. And if we operate at under vacuum, we can, for an 800 ton per day plant, we can use 1,000 kilos per hour of steam. That same plant operating at atmospheric pressure will use almost 2.5 times more stripping steam than the operation under vacuum. Other things we have to look at: if you're operating with a vessel that's under vacuum, we've got to minimize in leakage of non-condensables, such as air, to minimize the load on your mineral oil system. We've got to provide cooling if the material is going to be stored, maybe not so much cooling if the product will be processed immediately after. And like I've said here, that the benefit of the operation under vacuum is the reduced sparge steam load. Now what we'll do is we'll look at the vacuum stripper by itself. Here, again, we basically the vacuum stripper is up here. And some customers like to go directly from the vacuum stripper, and they pneumatically convey the product away to provide the cooling on the way to storage. Other customers like a cooler directly underneath here. And so basically what we're looking for is we need individual trays to provide product temperature control or time, really for stripping. We're adding the sparge steam in the bottom tray of the vacuum stripper here. We're controlling levels on each tray to provide good contact between the stripping steam and the white flakes. We have devices in place to minimize the amount of in leakage or ambient air. And again, we point out that some customers like the cool immediately afterwards. This system is installed in Brazil, and the vacuum stripper is up top. You can see these coils here are half pipes designed to prevent condensation on the inside of the vessel. This can be, you can use steam coils, or alternatively, we can use electrical tracing. And this is the cooler portion of the system, where we're a typical DC arrangement. This particular one was designed for 700 metric tons per day of white flakes. And we have designs on board for capacities as high as 1,200 tons per day of white flakes, be it canola, be it soy, or sun, depending upon customer requirements. I had mentioned that we have different ducting arrangements. This is the FDS, the flash desolventizer, mounted directly above the vacuum stripper with the cooler. This is a plant that's installed in Indonesia. A second plant is currently under construction, where a flash desolventizer has been installed with a piping arrangement to minimize the horsepower requirement. Again, these elbows are nothing but pressure drop. They provide residence time. They provide a lot of turbulence for product breakage, and with abrasive materials wear. In the case of palm kernel, which carries silica with it, you'd like to minimize wear. And you'd also like to minimize horsepower. So basically, different layout designs are available that, quite frankly, reduce the horsepower by as much as 40%. This, the plant that's currently under construction, I believe, is 1,200 tons per day of whole palm kernel seed. Sometimes we're making simply SPC, and where we are looking for a reduction, the majority of the product, we're looking for to reduce PDI to 60 to, let's say, 70%. We also want white flakes, large flakes, for downstream extraction that's being done. So in situations where we want to minimize the breakage of flakes, we'll use that DDD mounted above the vacuum stripper. The DDD will provide a nice reduction in utilities compared to the FDS. Quite frankly, sometimes for I think for 300 tons, the difference in horsepower for the DDD, connected horsepower for the DDD is, let's say, 5, which is, let's say, 3.5 kilowatts, and for the FDS is 250 kilowatts. The FDS has also been used, and there's two systems involved, 2 or 3, pardon me, systems that have been used in the world where product color is very, very important. Heat input to the product needs to be minimized to get the best product functionality. In situations like that, maximum time allowed for the majority of solvent removal is less than 30 seconds. And in those type of situations, the only type of heat device that heat transfer device or desolventizer that can be used is, let's say, a double flash line. This is installed in Europe right now, where the solvent is an alcohol, a hydrous ethanol. It's not hexane, it's not high strength ethanol, it's hydrous ethanol, maybe 35% water. Where a good portion of the evaporation takes place in the first stage. The product is collected in a cyclone, passed to a second stage, where, let's say, the residence time in here would be 2-3 seconds, and plus the time in the cyclone. And in here, it's, let's say, 3 to 4 seconds, plus the time in the cyclone. Pardon me, where we're going from, let's say, 55% moisture and high and product that requires a lot of heat input because it's hydrous, before it discharges at roughly 1% moisture and enters a stripper, a vacuum stripper. We had talked about applications for the white flakes. And so the primary ones are soy protein concentrate. This is where we make the Impossible and the Impossible burgers and other meat analogs. And so soy protein concentrate can be used as a filler for processed meats like salami, frankfurters, kibasi, sausages, where basically the product will hold more water after it's been cooked. Or worse yet, and so basically that would be one application. Another is the textured soy concentrates, where again we're making a meat analog. where it can be used as a replacement for schnitzel or beef or other different products. And these are a couple of applications where the product is a crumble as opposed to it's a crumble, and it's being added here as a powder. And in these particular applications, it's being extruded into that crumble and then formed again into a schnitzel, the crumbles here, or the chicken strips. This is a huge and a very, very high value, product, where we're taking the soy, I believe might be $450 a ton, a high pro, and we're converting that into a $600 to $700 a ton product for the white flakes. And when we start to get into these products here, they're $1,100 to, let's say, $1,500 dollars per ton, or even more, for the finished product. Another application that's really growing is soy protein concentrate in aquaculture and feed. And so let's say when we're feeding salmon, carnivorous fish such as fat, salmon, tuna, and other products that are other fish that are starting to be farmed, soy protein concentrate is a really good replacement for fish meal. And so soy protein concentrate is also important for the aquaculture as a high protein and less expensive. Typically, soy protein concentrate for aquaculture is made from a high pro soy meal, and the value of the SPC that's made for aquaculture or feed tracks the price of fish meal. It's generally, let's say, 30 to 40% less than fish meal. So if fish meal is costing $1,500 per ton, the soy protein concentrate will sell for $1,100. If the soy protein concentrate, if the fish meal sells for $1,100 or $1,200 a ton, then the SPC will sell for $700 or $800. The important thing to keep in mind is that it's possible to make pretty good money, pretty good margins when the SPC goes down to $600 or $700 a ton. SPC is also used to replace fish meal in calves and piglets' milk replacer. When I was introduced, we talked about specialty extraction, and this is white flakes are a very, very big portion, and SPC is a big portion of our product line. Crown does a lot of work working with other products. So what I'd like to talk about now is just for a little bit, what other products can we extract? And so using the same basic technologies of percolation or immersion extraction, it's possible to extract and dry a lot of other products that you might consider to be waste, as in the case of the fruit fibers. And you can have a valuable fibrous fiber add for addition to food. Other things like other insecticides like neem or perhaps pyrethrum, you can extract these products and sell them in a concentrated form downstream. So this is just a short list of other products that we've extracted at Crown. Whenever we work with new products, it's necessary to do test work. So we maintain a full pilot plant in Blaine, Minnesota, where we can test products on a 5 to 10 or 15 kilo basis, or we can do in larger scale equipment. We can test up to 6 tons a day in a percolation extractor. In our immersion extractor, which was right over here, we can test, let's say, 1 to 2 tons a day. We can produce quantities of material for testing, for product and market type of introduction work, and then also a confirmation of design. And with that, I very much appreciate your kind attention and any questions you might ask.
Thank you very much, Richard. We're going to have to also postpone the questions that you received to the Q&A session at the end during the panel discussion. in an effort to stay on time here. Thank you very much. Our next presenter is Rishab Goyal. Rishab is a mechanical engineer by education, but he's also an agile businessman. He's been working with the Goyum group since 2013, managing sales and marketing, and he's got experience with soybean extraction processes actually in sub-Saharan Africa. So with that, I'd like to introduce Rishab and bring him online here.
Okay. Good day, everyone. My name is Rishab Goyal. I am the Executive Director for Goyum Screw Press, a company based in India dealing in edible oil extraction, solvent, and refinery projects. So I will be covering Goyum company's projects in sub-Saharan Africa, particularly relating to soybean. So let me start the presentation here. First, we start with the introduction of the company. We started in 1971, and in the last 49 years, we have successfully commissioned over 450 projects worldwide. Our company is 9001 2015 and 14001 2015 certified company. We are certified by CE, which allows us to export our equipments to Europe and North America. We are turnkey plant and machinery suppliers in edible oil and fats, oleochemicals, and used engine oil sector. Goyum Screw Press is a 100% export-oriented company. We are currently exporting to 54 countries worldwide. We are also recognized by Government of India as an export house. The recent developments done by our company is we have developed a cluster, which is an association of oil expeller and its parts manufacturing enterprises. In that, what we have done is the government of India has granted an aid of to the tune of $2 million, which has allowed us to import world-class latest machineries from North Korea, so from South Korea and Japan. And the investment has been done by the government of India, and the whole investment is done by the government, and the land has been provided by the association. So this is a recent development done by our company. We have a vast network of international representatives. We have about 30 representatives who are marketing our products, partnering with us in various parts. Most of the representatives are based in Africa and Europe. We are also a registered supplier of United Nations agencies. We have been doing some projects with United Nations in Western Africa and North Africa. We have a fully equipped in-house manufacturing facility to undertake manufacturing of equipment with precision engineering under the eyes of a qualified team. We have a very qualified team of professionals who have vast experience in developing edible oil presses. These are some of the certificates which we have got from the government, from private as well as government agencies. We are members with the Solvent Extraction Association. It is one of the most recognized and premier associations in India for solvent. We are also part of the chamber, the Engineering Exports Promotion Council, the Federation of Indian and Exports Organization. So we are members of all the premium institutes in India. These are our business verticals which we are dealing in. The major business focus of our company is in oil pressing, mechanical oil press. Then we are also providing equipments for seed cleaning, seed preparatory. We are providing solvent extraction plant, complete turnkey projects for Africa. We have recently done a project in Tanzania and recently doing a project in Mali as well. Then we are providing edible oil, cooking oil refining plants. Then the vertical goes to oleochemical plants, palm oil fractionation, interesterification, esterification, and hydrogenation. We have also diversified into used engine oil refining. With the change of times, there is growing demand for recycling. So in order to be adaptable to this change, we have now developed machineries for used engine oil refinery as well. We have collaborations with rice milling, flour mill companies, animal feed plant manufacturers. As in Africa, most of the businessmen in Africa, they know the business plan, but they do not know which company to trust on and which company to source their equipments from. So we are providing rice mill, flour mill, and fish feed plants as well. Other equipments like crystallizer, which form part of the edible oil refinery, deodorizers, boilers, which form as auxiliaries for the extraction as well as refining plant. We are doing that as well. Now moving on to the soybean oil extraction process particularly. This is some of the detailed literature on soybean. It is, as we all know, it's the oldest cultivated plant in the world. People have been using this for 4,000 years. It's a high value material for animal feed and for human consumption, for human food production. It contains 42% protein and 25% oil. Soya needs special processing. Most of the companies in India, what they are good at is processing of cottonseed oil or sunflower, groundnut. But soya needs special processing, as it has, reason being it has anti-nutrients. Soybeans are processed for different purposes and with use of different. So Goyum from India offers effective solution for soybean processing, and it all starts with the preparation of raw material itself. So moving on to the process, soybean dehulling. So we are providing soybean dehullers, the cleaned soybean which are removed from any kind of impurities and are then dried up to 8% levels, are fed into the dehullers. Here, soybeans are compressed between the first pair of rollers, and as a result of that, the shells burst and the soya kernels break up into several parts. The mixture of soya kernels and hulls move to the transportation system and air separator. So soya shells, they are lighter in specific weight. So when the airflow moves, the husk moves up and passing through the cyclone. As a result, this process reduces the amount of fiber and increases the fraction of protein mass and improves the oil yield. The soybean kernels are then discharged from the air separator and fed into the extruder. Dehulling is done to increase the protein content in the oiled cake, or also known as de-oiled cake, DOC. After the dehulling process, the processed soya is then put into the extruder. So we are one of the few companies in India which produce complete soybean processing line. That is, we are making dehullers, we are making extruders, we are making presses, and the cake cooler as well. I'll explain in detail about the other two equipment. After the soybean is processed from the dehuller, it is going to the extruder. So the feedstock is conveyed forward by the screw inside the extruded barrel. Due to the high shear, it is then compressed, mixed, and heated. The soya is processed in less than 30 seconds under the great pressure and high temperature. So any kind of harmful substances which are present are destroyed in this process when the temperature inside the chamber or the barrel is 130 to 140 degrees Celsius. At the same time, protein and fat do not lose their property due to the short time of cooking of the product. Our extruders are based on dry extrusion method. The heat is developed by friction. And what we have got now is a full fat soy meal with the help of screw feeder. Then this feed is being fed into the mechanical oil press. So I would like to particularly focus that our machines are probably the only company machines from India, or you can say Southeast Asia, which can process soybean and give world-class results acceptable for all acceptable for the world market. So our machine is performing very well in India as well as in sub-Saharan Africa as well. So the mechanical oil extraction in the oil process is the third point. The full fat soya meal is then moved along the press cage and is squeezed and pressed. And due to this high pressure, the oil seeps out through the press cage gaps and is gathered into the oil reservoir below. What we are getting is a pressed cake with an oil content of about 6 to 6.5% and a temperature ranging between 110 to 120 degrees Celsius. So what we have done after extrusion is we have extracted the edible oil, soybean oil present in the soybeans and got soybean oil cake. After this process, the cooling of the oil cake is an important part. I want to point out that the trypsin inhibitors is removed by the extrusion already. So there is no need for heating by the dry extrusion already. Whereas in case of other oil pressing, like in case of groundnut, sunflower, you need to provide steam before you press the oil seed. Whereas in case of soybean, all you need down. It can't be packed as it is, as the temperature of the oil is about 110 to 120 degrees Celsius. So the oil cake, after passing from the hammer mill, is fed into the cooler. The cooler tumbler rotates and steers the oil cake down to the discharge section. The fan creates a flow of air through the soya oil cake. Heat exchange occurs between the cold air and the hot soya oil cake. So after the cake has been discharged in the cooler, its temperature is roughly 40 to 50 degrees Celsius lower than the temperature what it had at the time of feeding. So the oil cake, having its temperature at least 50 degrees lower than its feeding temperature, can be stored, and typically it can be stored. Online cooling is also required. Online cooling is required for online bagging so that stacking can be done. So these are the 4 basic steps which can get the perfect ingredient to be used in feed industry. Only mechanical pressing can get oil, high protein and soya cake. In conclusion, let me remind you that high temperature and short time cooking is the key to successful soybean processing. Using our technology, it's available and it's a reliable technology. So these are majorly we are marketing our products in. We are basically marketing our products in sub-Saharan countries. Like when you say sub-Saharan, we are starting from Egypt, Sudan, Ethiopia, Tanzania. Then if we move towards the west coast of Africa, we are working in Senegal, Mali, Togo, Benin, Ghana, Burkina, Cameroon. All these countries, there are businessmen who are using our processes, our plants on soybean processing. We have done projects in Zambia as well, in Mozambique as well for soybean processing. So particularly talking about our experience in sub-Saharan Africa, we started our journey in year 2000 from Uganda. So in terms of exports, we have been exporting since 20 years now. This is the 20th year of export of our company. So we have had a great experience in sub-Saharan Africa for 2 decades now. We started with Uganda in 2000, and then subsequently we ventured in Tanzania, Zambia, and Mozambique. And most of the projects, I remind you that about 30 to 40% of the projects are based on soybean, and the project capacities are not of major like 200 tons or 500 tons per day. They are basically medium scale capacities, 50 tons per day or 100 tons per day maximum. So we're working in all the East Africa region of Tanzania, Zambia, and Mozambique. In North Africa also, we have done turnkey projects in Sudan, Ethiopia, Egypt. In West Africa, we have been working in Burkina Faso, Mali, Senegal, Ivory Coast, Nigeria. Some of the countries, some of the entrepreneurs in these countries, they are using machines on multiple seeds. So one season, the availability of soybean is there, the harvest is good. So they're working the machines on soybean. next season, when 3 months down the line, they feel demand for cotton seed or the sunflower seed is increasing, so they're moving to the sunflower and other crops as well. All in all, we have done in terms of exports, we have turnkey for edible oil extraction, refining, solvent, out of which we can say about 31 projects, 10% of the projects are primarily working on soybean. So it's a highly specific seed, and due to which the process is also highly specific. And there are few companies. There are companies in China, in America, in Europe, which are providing full processing line for soya, mechanical processing line for soya. But in India, I can say that Goyum is one of the few companies which has given complete turnkey working, successfully working plants in most of the cases. Most of the projects in soya, I want to focus, they are working on 50 to 150 tons of capacity. The reason being is most of the African sub-Saharan economies, they are basically of a population range of about 20 million, 40 million, 50 million people. And the crop size are also not very huge. So they need to be made sure that if they put a plant, let's say of 50 ton capacity, they should be able to work maximum time, at least 300 days a year. So to do that, they do not go in for a 300 ton or a 500 ton project because the feasibility is not there. The crop size is very small, so they can't afford that. Putting a 500 ton plant, they need to procure 500 tons of soybean every day, which is a difficult task in sub-Saharan countries. So most of the projects which we have done are ranging between 50 to 150 ton capacity, which is a feasible capacity to work on for those businessmen, entrepreneurs. They can procure 50 tons of soybean from their sources and get a feasible return on their investment. Let me move on to the next slide. This is detail about extraction for soybean, which I have already detailed. Then the process comes for refinery, solvent extraction, and animal feed. So these are the other verticals in this line. Soybean intake. So I'll like to show you some photographs of our manufacturing facility. We are based in Ludhiana, Punjab, and we are completely in-house manufacturing, which we are making here. The presses, extruders, coolers, dehullers, and hammer mill, they are all made in-house. Nothing has been procured from any other sources. So we have an excellent manufacturing facility equipped with all the latest machines. Like I said last, we have procured machineries from South Korea and Japan as well. So we have a skilled team of engineers who are dedicated to provide good quality equipment, and we have a long experience. So the experience helps us to market our product and to provide good after sales service to our customers as well. So these are the few glimpses of our manufacturing facility, which we do here in India. These presses on your right of the screen are all for soybean processing. They can work on soybean, on sunflower, on groundnut, cottonseed, on multi-seeds, palm kernel as well. These are the manufacturing facility we have. These equipment are for solvent extraction plant, which we are now doing in Mali. A project, we have grabbed an order from Mali for Shea and soybean. Also, there is a project. These equipments are also for soybean, so refinery and solvent, which we are doing in Kano now for Nigeria. So there's a growing demand in North Africa as well as Western Africa. Sub-Saharan Africa, my personal point is that due to this COVID-19 pandemic, more and more economies, more and more businessmen are now focusing on self-sufficiency rather than being dependent on imports. More and more businessmen and governments are focusing how can they make themselves self-sustainable. So we are looking at now, we are getting inquiries from people who were earlier importing soybean oil or sunflower oil from Ukraine or from Brazil, Argentina, and now they're looking into venturing and putting their own factories for edible oil processing. So at least one good thing I can say from COVID-19 pandemic is that the businessmen are thinking inwards, trying to integrate themselves rather than being dependent on imports. So that's why we feel companies like ours have a good opportunity to work in sub-Saharan Africa. We have a long experience there. We have a good team of professionals there who are working tirelessly. So that helps us to market our equipments as well. These are again some photographs of our equipment getting ready in our factory. Again, photographs. So these are some of the technological highlights, and we focus on providing maximum efficiency. So luckily we are in Punjab, and we do not have any labor issues or any kind of these issues. So which allows us to work full time, 24 hours a day. We are working in double shift, 7 days a week. So we are quite efficient, which helps us to provide all the equipments in a stipulated time. So what happens in sub-Saharan Africa particularly is the delays happen because of bureaucracy and red tape. So to counter that, we have a hugely efficient team in India who make sure that whatever we commit to our customers in Africa, we deliver on time. So our equipments are also, they consume lesser electricity, so the utility consumption is reduced. They provide better performance on the reduced utility. Our process costs are also reduced because of this, and we are using advanced technology, so this helps us to reduce the downtime as well. So I would like to give you an example that if a competitor company, they are selling a machine in Africa, sub-Saharan Africa, and the shelf life of the parts is like 1,000 hours, whereas in our case, our equipment, the same part lasts for 5,000 hours. So you're looking at like 5 times more time limit. So you can run the machine for 5,000 hours without any stoppage or breakdown, and it reduces your downtime. It increases your productivity. It reduces by that helps us to market our product as well, and that increases the confidence of our customers as well on us, that the Goyum's machine, they'll be satisfied that, okay, I can work 300 days a year without any undue delays of stoppage of machines to repair and maintain. So that's an advantage in choosing Goyum. These are the competitive advantages we have, like they are mentioned in the previous slide as well, the design and the maintenance costs, reliability, the ease of operation as well. These are the photographs of some of the projects we have done. As you know, India is also a huge soybean producing state. So we have done a complete soybean edible oil extraction plant of 400 tons per day. It is operational in India and working very nicely here. The demand for soybean oil processing previously, 3 years back, it was all solvent extraction. But due to the American and Chinese trade war, the tariffs and all, it has led to increasing demand for soybean cake in Europe and Canada and North America. So what is happening is Indian processors, Indian solvent extraction companies, they're now putting their own mechanical extraction projects. They are scrapping the solvent plants and putting mechanical extraction processes, and whatever cake is being coming out, they are all being exported from India to Europe and North America. So this is that is what has helped us. And similarly, this thing has helped us in sub-Saharan Africa as well. The demand from soya cake from sub-Saharan food. So many of our customers in West Africa and North Africa, they are using this facility to export export soybean cake. These are our soybean oil process machines abroad. We have done in USA as well, in Nebraska, and we have done in Australia also, New South Wales, just in outskirts of Sydney. We have done 2 projects. Soybean solvent extraction. We have also done projects for soybean solvent extraction in the past, and currently we are doing. These are some of the pictures of the projects which we have done in Africa, and on the right, the picture we have done in India. The projects are under installation. As I told you, because of COVID-19 pandemic, more and more businessmen, business houses are moving towards manufacturing to integrate their supply chain, backward integration. So we have got good orders for extraction, solvent extraction, as well as refinery and mechanical oil pressing. So we are doing currently project in Kano, Nigeria. We are doing in Mali, Sub-Saharan Africa. So the order book is quite full. The refinery installation is also going on in Tanzania. Dar es Salaam, we are doing a soybean oil refinery. It is also under operation. These are the few photographs of the feed factories. So we have done a project in Uganda recently for a company, and they are working on fish feed and animal feed. They are using soybean cake, and it's a 10 ton per hour capacity plant, completely supplied, machinery erected, installed, run, design, everything is done by our company. And it's a complete turnkey project, very nicely installed project. And they have even planning to make enhancement in this line. So we are in discussion with them. So this is also a project done by our company in Uganda. These are some of the awards and achievements. So since we are in the business for past 50 years and in exports for 20 years, so company who are dealing in exports are bound to have some kind of accolades from the associations and from the society. So India Mart is a very renowned portal in India. They have awarded us in year 2012, 8 years back, for having good policies and taxation and bookkeeping. And we are also among India's top 500 SMEs. This year, they gave us this recognition. The government of India has also recognized our efforts to boost exports for agricultural machineries to Africa. So they have also awarded us in year 2010. We have been awarded the Economic Development Award by the Forum in 2009. These are some of the credentials of the company. Which we have got ISO CE DNB certificates. He is the chairman of the company, Mr. Vinod Jain, and he is the founder of the company 20 years back. He is the one who started and ventured into Uganda, and since then it's a joyride. There has only been growth in the past 20 years, and we hope that the company grows from this end also. These are the details of the project. So we are totally based in Ludhiana. It is called as the Manchester of India. So the manufacturing is good here. There are a lot of companies, a lot of professional brains are there. So we have about 400 different units in Ludhiana, and we have an area of about 30,000 square meters covered area, where we all these 4 manufacturing facility. 2 units we have in outskirts to manufacture our refinery and solvent equipments. As they are volumetric equipment, they need some space. So I would like to just introduce my colleague, Mr. Jeevan Joshi. He is an expert in oil refining and solvent. So he will just share some notes with you for solvent extraction process, which we have done in Africa, in Sub-Saharan Africa particularly. Okay.
Greetings of the day to all of you. So here I would like to come back to our presentation slide of the soybean oil extraction with turnkey solutions. When we are talking about the turnkey solutions, so it starts from the soybean intake inside the factory. When the soybean is coming inside the factory, the first and foremost thing is to get the proper intake of the soybean and to have a very proper pre-cleaning section for the soybean. So for choosing the correct machinery for doing the pre-cleaning of the same, we need to choose the correct equipment with the correct capacities, because the intake is dependent upon the truck size of the particular country. Like the 35 metric ton is the total truck capacity. So we have to decide that in how many hours we are going to do the offloading of the truck, and how many trucks we are going to handle in 1 hour or 2 hours. So the capacities of the same can be decided with respect to that. Okay. Now, the second thing is, once we are done with the pre-cleaning, it is our next step is to lift those soybean to the storage silos, the grain silos. Now, to choose the optimum grain silo is also again the important thing. Here in India, we are manufacturing. We have done the partnership with our sister concern companies who are making the silos, and we are all in our Goyums. All the silos we are using the zinc-aluminum steel, and we have already installed more than 25 silos until yet in various soybean factories. After storage of the silo storage is also being calculated depending upon the number of days you want to have the storage for. Like if you want to have the storage for 15 days, then the capacity of the silos will be calculated as per that. If you would like to have for the more number of days of storage, then it will be calculated as per that. Okay. Now the third thing comes for the post cleaning. Now the post cleaning will be done for the soybean. After that, the next step comes as the preparation of the seed. Now the preparation of seed depends upon what kind of final product we want to make. Like if we want to make the full fat soya meal, then we need not to go for the dry extrusion. Then we can go for the wet extrusion as well. And if we want to extract the oil by the mechanical method, then we have to go for the dry extrusion. We can't go with the wet extrusion, because if we'll go with the wet extrusion, the moisture content will be very high in that. It can go more than 12%. And if the moisture content goes more than 12%, then it is very hard to extract the oil out of it. And it is very hard to get rid of the moisture from the wet extruded material. So it is the best process in order to make the full fat soya meal. But when we are going to extract the oil out of it, then we can go with the dry extrusion. The third option is when we are going at a very high commercial scale of 1500 metric ton or 3000 metric tons per day capacity, then in that case, we need not to go for the extrusions. We can go directly with the soya preparation. In the soya preparation, we have the means after post cleaning, we have the dehulling, we have the partial dehulling as well, and we have the full hot dehulling as well. The full hot dehulling, when we are doing, that is called the full complete dehulling, and that full dehulling is increasing the capacity, increasing the okay, I'm just closing it very fast. So dehulling, as Mr. Rishab has told, that we have hot dehulling also, and the partial dehulling as well. So means my purpose was for telling this all in brief detail, that the Goyum has a part to do the complete turnkey solution from the intake to the product and end products. So I hope our presentation is went off. So now we can start with the question and answer session. If anyone have any questions, we are here to address the same. Thank you so much.
Thank you.
Thank you very much. We want to get started on the Q&A. I think we'll be bringing the rest of our speakers back. Thank you, all of our speakers. We have several questions that have come in. The first question was directed to Bart, if you're ready here, Bart. The first question was, what is the effect of the nanoreactors creating the cavitation on the final quality of the oil?
Basically, there is no effect on the final quality. There is not negative, because you might think about negative effects, but there are none that we are aware of. We have the same shelf life, stability of the oil. Okay. The only thing is this ice-shear mixing allows to work with less chemicals. Mm-hmm. And due to that, we have a yield, small yield increase of something like 0.2%. Of course, this value depends on the initial FFA and phospholipid content. But globally, due to this, we can improve the process economics.
Thank you. We have a question for Richard. Richard, one of the questions was, what do you recommend for optimizing quality and environmental sustainability with your desolventizing systems? Which would be preferred?
Well, that really depends. Both of them will, from an environmental point of view, they're going to be equal.
Okay.
Really, what it comes down to is your product requirements and where you'll be selling the product would be more important than would be the most important thing in regard to a selection of the FDS versus the DDD. We recommend one thing we do recommend is the vacuum stripper under vacuum because it minimizes leakage, and any leakage is inward. And leakage that's inward can be controlled. Leakage that's outward is a vagrant loss. So we would say that the DDD and FDS are equal, and that your product requirements, let's say SPI, isolate, I'd be inclined to use a FDS because the product will have a higher PDI and it will be lighter in color. SPC capacities to 300 tons a day, I'd go probably DDD. Okay. So basically, your product and your market drives, and impact on environment is the same.
Okay, thank you, Rishab. We have a question for you. What would be the ballpark cost of a soybean turnkey solution? And they didn't specify a volume, but maybe something typical like you've talked about in Africa, I suppose, in that 50 to 150 ton a day range.
So Mark, 50-ton project for soybean, about $80,000 we can give in sub-Saharan Africa.
Okay.
These are very, I would say, budget projects to enter into. One of the easiest projects for sub-Saharan people. So if an entrepreneur, if he has an investment of $80,000 or $100,000, it's one of the easiest projects for them to enter into, because the raw material is available locally in sub-Saharan Africa, and the finished product can also be used in the local market. So they need not to go to exports or import of any raw material. So that is what helps us to market our products in sub-Saharan Africa, because the raw material is available locally and the finished products can also be sold locally.
Okay. Bart, you also have another question. Does the enzyme treated oil produce a higher quality oil, and is it more environmentally sustainable? And then the second part to the question is what's the cost differential?
Well, that is a very
open-ended
complicated question.
Yes.
No, the first thing is, if we do physical refining, we can achieve an oil quality which is just as good as chemical refining. But there are a few conditions. So first of all, the degumming has to be done properly. So the phosphorus has to be low enough. And also at the outlet of the bleaching, the phosphorus has to be as good as in chemical refining. If we go into the deodorizer with elements, we get problems like darkening. Now, the second thing is, the deodorizer should, of course, be adapted to be able to do the physical refining in a correct way, because there are things like trans-isomer formation, which require a setup in the deodorizer which avoids these negative effects of, for instance, trans-isomerization. But nevertheless, there is an advantage of going for physical refining, even with soybean oil. And if the quality of the oil and the beans is good enough, you can achieve the same color with physical refining and enzymes than with chemical refining. Because usually the first reflex is that the oil will be darker when you do physical refining. But we have seen, if you have really a good bean quality and oil quality, you can get the same quality with physical refining. I think if you have medium quality or bad quality at the end, people will stick to chemical refining.
Okay. And Richard, you talked a little bit about your pilot plant capabilities right there at the end. Roughly what capacities do you have in terms of, solvent extraction in your pilot plant and also in terms of desolventization?
For solvent extraction, we can demonstrate and as capacities as small as 5 kilos an hour to 6 tons per day, currently 6 tons per day. Desolventization, probably 20, 30 kilos an hour to that 6 tons per day. We have plans to increase our capacity to as much as 1,000, get my scale correct, 11 tons per day, and white flake desolventization to that 11 tons per day. So really, now that I say that that's based on hexane.
Okay.
So if you're going to come and the solvents like ethanol will have a higher heat requirement and it will be lower. So the way we view this, our pilot plant, is number one, when we develop a process or a new material, we can do it on a very, very small scale with 5, 10, 15 kilos and demonstrate the operation of an extractor. And then when we can also help do small market scale quantities of material as high as 11 tons per day input to the pilot plant, and with desolventization capabilities as high as that.
Okay, thank you. And Matt, a question for you. You mentioned the need for very flexible multi-oil types of little refineries that also have blending capacities, that sort of thing. One of the issues is always, flush and that sort of thing. Are there ways of designing or ways of dealing with that issue, which otherwise, kind of sometimes becomes a yield issue or a quality issue?
It does become a bit of a quality issue because the material that you get from a flush system, most commonly a pigging operation,
Yeah. Mm-hmm.
You do get some material waste as a result of that. And depending on your quality constraints, that can end up being a loss.
And Rishab, one question for you. You mentioned, your partially mechanically defatted products. Do you have any customers that are making textured vegetable protein type products from these mechanically de-oiled products, cakes?
Yes, I would like to give the answer of this question, that if we are talking about the high protein content and the customer, we have around more than 30 customers here in India who are making the high protein oiled cake from our oil presses, and they are already exporting into the European Union, most of the Europe countries, and also exporting to the US as well.
Okay, thank you.
Yes.
And Richard, another question just popped in. It said, in your presentation, you indicated that soy flour is made from 20 PDI flake meal, but you said that soy flour can be used for beverage with low PDI, and that they were just wondering about the low PDI being used in a beverage application.
It's a really a great question, and again, it depends upon the end use of the product, in the sense that, let's say a high PDI product there's no reduction in the urease. So let's say for white flakes that make a feed material for let's say soy protein isolate or concentrate, the feed material is enzyme active, and we depend upon downstream processing, be it cooking when you're baking a donut, or when you're cooking a donut, or when you're texturizing, or when you're making isolate or SPC. We rely on downstream processing to neutralize the urea, to degrade the urease that's there, the anti-nutrient activity. If you go to a product where you're going to add protein directly to a food product like a milk or a high energy drink, it's necessary to reduce the urease activity up front and in the white flake desolventization process. So basically, what we need to do is provide conditions, which is high moisture and time, without affecting the color. Because basically, I mean, you can take, let's say, for instance, you can take an extruded, a pressed soybean or a high pro that's tan in color, and the customer is selling a milk drink. He wants that product to be white or as close to light color as he can. So the flash desolventizer and the vacuum stripper can be operated in a way that it maintains color. There will be some loss in color, but we can neutralize the urease so you can apply it directly to that energy drink or a product without affecting let's say digestive process.
Okay. And I think this is a question that I could just toss up to the panel. Someone's asking about the removal of oil from liquid lecithin, either by acetone or other means to make powdered lecithins. And the question is basically, are there turnkey solutions for that?
I can ask.
Okay.
I can answer that. Powdered lecithin is really a tough product to work with by itself. It's an oil, and so what you're really trying to do is to put it into a form where you can sell it as a dry, free-flowing product. And there are ways to do that. There are ways to do that, Mark. I'll bet you are aware of a few, but there are ways to do that that involve addition of a free flow agent or things of this nature that can be added that will a carrier or a free flow agent, depending upon the terms that you come to, that will create that end product for you. Turnkey, turnkey is on an installed basis, probably not, but supply of equipment, sure.
Sure. Okay. And I think we've got one last question here. And again, I'll just toss this out to the group. I see, I know Bart had some time conflicts and he may have had to step away, but how would you address the conflicting demand, lowest color versus TFA increase, trans fatty acid increase during physical refining? So on one hand, you want low color because you're trying to deodorize at higher temperatures, but then you also are trying to reduce trans fatty acids. And so if I'll just toss that up to the panel. But yeah, it was really, I think, a question that they meant to ask Bart, but he's unfortunately had to leave. But anyway, I think that is all the questions. I really want to thank all of the speakers for your great presentations today. This whole session has been recorded. It will be available to the registrants for the meeting, and so if you didn't get a chance to see every bit of it today, you can go back and selectively review or also just review the information. I want to thank AOCS for making this Soybean 360 conference possible. And if you, there are other sessions on other topics in the upcoming days. And I just thank you all for your attendance and attention. And I really like the fact that this was a very international one. So between folks in Minnesota and Ohio, clear out to India and Belgium, it was a very, it was a great experience. Thank you very much.